Welcome to the Impulse Spotlight, a podcast for product development professionals. In this episode, we speak with the Director of Engineering at Trim-Lok, a company that specializes in the manufacturing of rubber and plastic extrusion products. Trim-Lok's high-quality sealing and trimming solutions are used across various industries, including automotive, marine, industrial, and recreational vehicles. Our guest today has amassed a wealth of experience working for various large and small corporations, including Lockheed, Pfizer, Mattel Toys, and Rainbird. He's earned a total of 12 patents and founded his own development company, 2N2, which specializes in industrial design, product design, and tooling design, creating everything from housewares to computer electronics. Beyond his professional achievements, he's a dedicated family man. He's been happily married for 21 years and is a proud father to his 19-year-old triplet boys. In his free time, he enjoys woodworking, playing golf, and working out. Ken Siegel has been a driving force at Trim-Lok for the past 18 years, but Ken has a lifetime of design and development experience, holding down every role from inventor to executive. Today we begin by discussing a folding hanger and a specialized plastic handle, two products Ken personally developed and brought to market. Ken recounts his diverse experiences working with a cat litter company, as well as his time at Procter & Gamble, where his strategic influence had a direct impact on the trajectory of their Tide products. He also shares an example of a custom extrusion project and how his team successfully overcame the obstacles they faced. Throughout every story or example, Ken provides valuable insight into the importance of adaptability and resilience in product development, emphasizing how failure can serve as a powerful growth mechanism. Ken hopes to encourage aspiring product developers to stay persistent and never give up. Let's get into it. Hey, Ken, welcome to the show.
Thank you. Pleasure to be here.
Great to have you. So, as I always start this out, I tell people, I started Impulse 25 years ago after working for a product development company that had, all facets of product development under one roof. I tell them, I say I got my master's degree working for that company. Tell us about how you got into product development.
Well, many years ago, my first job out of college was Lockheed, which I was developing machinery for in manufacturing. And when the plant shuttered, I had a chance to work in the private sector at a biomedical device company, and did some good things on the manufacturing floor that got positive reviews with my management, and they promoted me into product development of a next generation biomedical device. And that's what I like doing. I like developing the products, whether it's assembly aids or what have you, within that company. And they put a lot of trust in me to develop a whole next generation device. And basically my product development career was launched at that point.
Very cool.
Yeah.
And so tell us about the product or products that you'd like to start off discussing today.
Well, we can go through, I've developed many products from concept into the production. I could talk about some personal projects, a hanger that I developed in 1988. I could talk about a handle, very simple handle that was used in flexible packaging. We could start there with those two. Those are my own personal products. And then I have many with industry.
Yeah, let's start with the hanger. Tell us about that.
So I had just moved to California, and I was going to be going out for the evening, and I actually had it was like a shirt, a sweater, if you will. It was hanging up in my closet, and I went to pull the hanger out from the bottom, not from the top or the collar, and the hook, it was a wire hanger. The hook got snagged. Gets snagged on the inside, and I didn't know that, so as I pulled the hanger out, it caught the thread, and it left a hole in my sweater. And I was not happy about that. I ended up not going out that night. The light bulb went off in my head. I sat down. I actually drew the design, which was a spring-loaded folding hanger that could install or insert through the collar of your shirt. And yeah, I started from that, and did not go out that Friday night, and designed that. And what followed was trying to figure out how to get the prototype made. Um, this was back in 1988, 89 timeframe. So I found a guy that was a machinist, and he machined the very first version of it for me. I assembled it with a torsion spring, and the the hanger was born. The folding hanger was born for me. And the way I designed it was the arms would fold not down but in, and then
Okay.
you would fold them in and then draw and put it in the shirt and then let it spring out. And then over the years, I patented the product. I sold the product through the Hammacher Schlemmer Sky Mall magazine, which was very interesting and great experience. Um, I had a lot of interest with companies like Bed Bath and Beyond and Linens and Things and so on, but they never got me into their planograms. They had these planograms, and I could never get into the planograms. So, but what was interesting was that I licensed this product to a large hanger manufacturer that sells to Targets, Kmart's, Walmart's, and they bought my inventory. Over the years, I had redesigned it. I had it molded in China, and I had made some inventory. I made improvements to the product to go from 6 pieces down to 4 pieces, and that's the product that I ended up licensing to this hanger manufacturer. And it was supposed to be sold to Linens and Things under a brand called Taylor Select. And long story short, they went out of business. Linens and Things went out of business, and the product never made it, and I never received royalties. I did receive a nice check for all of my inventory. I just never got my royalties, which would have been really nice.
Yeah.
So,
Take us through I mean, I know it's been a while, but take us through kind of the development of that. What did it look like from that concept that you made that night to actually get finished product?
yeah, so it started with the machining. The very first one was machined out of ABS plastic. I then, since I'm an engineer, mechanical engineer, I um, uh, designed this for injection molding, and I made some initial casted hanger arms. So I had to kind of, it was like a very, it was, step by step. Sometimes, well, in the development process, you got to make mock-ups. You got to, figure out ways to do this on the cheap, and and test before you spend the money to make the mold and this and that. So I had done some castings of the arms, which it was good for maybe 10 or 20, but it got me
So
the
when you say
point of,
casting, when you
I'm
say
sorry.
casting, you're talking about RTV silicone
Yeah,
RTV molds.
RTV molds. So
Okay.
where they pour the plastic in and let it set. I had sourced the wire hook. At the time, it was a 6-part assembly, and I had sourced the hook. I had these push nuts that I had sourced just through a catalog that you push on that holds the hook in place. I mean, if I could show you the product, picture and stuff like that, you understand. And but that's what it took, is I had to do that. I had to test it. One of the problems with the hanger was the very first version was the hook axis was aligned to the center axis of the hanger body, and that didn't work, especially for, and it's very important, that didn't work because the weight of a garment, whether it's a shirt, a sweater, what have you, would tend to want to pull the hanger arms forward,
Mm.
and it wasn't holding. So I shifted the center axis of the hook forward and kept the arms back. And by doing that, it allowed the weight to rest on the arms, but not want to bring it forward. So it's kind of, that was a development that came with testing, of course,
Sure.
with after the mock-ups and so on. So that is one of the design pivots that I had to take. Once I understood that, then it kind of took off from there. I added features. You could close the hanger arms together. I added an end of arm feature that you could snap them together and travel with it. I even had a version where the hook would fold down, but that was getting even more complicated. So I actually designed it. I didn't produce it. So with those mock-ups, the RTV molds and so on, it allowed me then to get to hire somebody to design the single cavity injection mold. And with that, the hanger was born, and that was the version that was used to sell to Hammacher Schlemmer Steinmal. I employed a bunch of my friends to come over to my townhome at the time in Redondo Beach, and we sat there all night assembling hangers, which was my first shipment to Hammacher Schlemmer. I still remember that day and that night where I had to create a little jig to preload the torsion spring, because I had a really good friend of mine, Jody, who she wasn't very good with the spring. It's tough to have to preload it. So we were assembling hangers all night long and then packaging them in a 3-pack. And the packaging was a whole other aspect. I realized I went to the store and like a lot of these hangers were packaged in 2s or 3s or 6s or what have you. And I had to design, and that's where I spent some money. I spent more money probably on the packaging side than the product side, because I wanted the graphics of the product to basically showcase what the hanger did, how it functioned. So people, when they look at the package, they can understand, oh, this is a folding hanger and not just a regular hanger. So it was a process. It was, the whole thing from start to finish.
Very cool. So talking about packaging is probably a good segue to start talking about the handle that you had mentioned. You want to tell us about that?
Yeah, good segue. So I was working for a company called Portola Packaging up in the Bay Area. I was a business development manager / engineering director, kind of a hybrid role, and looking at new packaging programs that we can look at as a company and so on. And I was attending a flexible packaging conference in Orlando, Florida. A gentleman stood up with a cat litter bag, a 14-pound cat litter stand-up pouch, if you will. And it had a die-cut hole in there for the person's hand. So when you go to the store, you can pick it up using that die-cut hole. And he stood up and he said, hey, and he had it ripped. It was ripped. It wasn't together. And he said, does anybody have a solution for this problem that I'm having? And they ran a cat litter manufacturing plant and distribution plant there in Florida. My light bulb went off again. I sat there in the conference, and instead of focusing, I hope Portola is not listening. Instead of focusing on what I was there for Portola packaging, I came up with a handle. I said to myself, well, the inside of the bag is, I know what the inside is. It's low density polyethylene. And I said, if I created a reinforcement to heat seal or ultrasonically weld into the bag on the inside, that would spread the weight of the weight distribution of the pouch over that surface area and make it much stronger. And so I was drawing this thing up on the plane flight on the way home. I'm sitting there just brainstorming. I got home. I incorporated 3D printing and made an SLA. Of course, it's not this low density polyethylene plastic, but I made a bunch of SLAs. I wrote to this gentleman. I called him on the phone. I said, I have a solution to your problem. And that was literally days after, maybe a week, 5 days or so after. And I said, I have a solution to your problem. I then, with my rapid prototypes, the 3D prints, we talked on the phone. I told him what it was. I sent him a sample. He had signed a confidentiality agreement. I made sure I always did that with people I was sending things to that I invented or came up with. And I sent it to him, and he's like, he looked at it and he's like, when can I have it? When can you produce it? And I'm like, I wasn't expecting that to happen right away. And so I had to quickly make an injection mold, a single cavity injection mold, and again, spend money, but I tried to limit how much money I was spending. Here we go. I'm going to, spend more money. And so I invested in a single cavity mold, injection mold. I had a company local here in California make the product for me on the cheap. I picked a company that could do it and not charge me a fortune. And I sold these handles for about 6.5 cents a piece, where I think I molded them for 2.8 cents or so. And then you have to package them maybe 100 to 250 in a box and send them and so on. And so I made a profit on that. The interesting thing is we had to figure out a way to heat seal them or ultrasonically weld them in the bag. So he had asked me, again, all in this time frame, how are you going to do that? So I employed a gentleman on an automation company, and we made and designed a heat sealing apparatus to have a shuttle that would hold the bag. You would insert the handle through a pocket. It shuttles back in, and then the operator hits the button. It presses down for about 6 seconds, heat seals, and then it shuttles back out, and then they replace, and they just go. He bought that piece of equipment. I did make some money on that as well, and I continued to make about 3 million handles a year with increasing volume. From within 6 weeks of that conference, I had a customer and I was making money. With the money I was starting to make, I invested in a 4-cavity mold so I can drive my costs down and continue to make a profit. That money from that product alone paid for my wedding. So,
wow, that's cool.
Yeah, that's the story. The biggest... And I have a lot more stories about that product and the interest that received over the years.
Yeah, that's interesting. What was the biggest challenge you had to overcome in developing that?
I would say probably the development of the machine. That the product was very simple. It's a low density polyethylene oval. Simple as that. It's an oval. So it wasn't that sophisticated. And that's the key here, is that the products that are the most simple sometimes are the best products that make the most money. And so I tried to keep the product simple. And the challenge was getting the handle sealed into the pouch, the stand-up pouch, where we can do them on a quick basis. So we were at a point where it was maybe 10 bags a minute, and that wasn't fast enough for the company making the bags, the Cedar Fresh cat litter company. They made Winn-Dixie cat litter. They made all this different cat litter. So that really wasn't quick enough. So with that product, I was actually pursuing full-scale automation to be adapted to the pouch making machinery, so that and the bag making machinery, so that you can have how they have those zippers in pouches where you can zip it together and seal the bag. Yeah. It's the same approach. I created a piece of equipment we were designing a piece of equipment to adapt to the pouch making equipment, so that the handle can be installed at that time frame in line versus after the pouch was already produced. And so with that would have upped the speed tremendously. But I think that was the biggest challenge, was to get these in a timely fashion to keep the cost down of assembly. the making of the product, the designing of the product, and the injection molding was pretty simple.
Sure, sure.
Yeah.
Did the cat litter company have exclusive rights to that, or were you able to kind of parlay that into selling it to somebody else?
They did not have exclusive rights to it. I was using that as leverage to, I started to market that all over the industry. I was in flexible packaging, magazines. I basically created a whole company around that called 2 and 2 Flexible Solutions. And I was creating automation all of a sudden. I started with a little simple product, and the next thing I know, I'm creating machinery to install that. So it was pretty much becoming a machinery company at that point. And I had Hewlett Packard for inkjet bags. They were calling, asking me, okay, I want to put your handle in two of the handles in the inkjet bags so that we can hang the inkjet bags inside our printers. So that I had interest from Hewlett Packard. I'm like, oh my God, I can't believe this. I had interest from Procter and Gamble. That was the largest situation I could have imagined. They wanted me to present my handle or a version of it to their executive staff in Cincinnati, I believe. I remember, I think it was Cincinnati, that to their executives for Tide. They wouldn't mention it at the time, but it came out later that it was for Tide. It was kind of secretive. And I got picked as a top 4 out of about 16 presenters. The version of handle that I created was a handle that had similar to my handle, but I extended the top and the bottom so that it supported the pouch, because they were trying to put Tide in a pouch rather than the bottle. And I extended it so that it had more support over the surface area of one side of the bag, so that when you picked up the bag, you could pour it. And they loved it. They absolutely loved it. And I was sitting there counting the pennies that I would be making if I can get into the volume of the production, which was like, I think the starting volume was 250 million. And, wow. They Tide is, they make this thing global. And so I tried to parlay that simple little low density polyethylene handle into many different things. And it did take off to a certain point, but unfortunately, the Cedar Fresh Cat Litter Company sold their whole brand to a private equity firm. And I struggled with the president of the private equity firm to keep the handle in place. And I don't know if you know about private equity companies. They like to strip things down and sell them off in pieces. They wanted to take my 6-cent handle out. And I said, no, you're going to destroy the brand, the brand that they created over the last 3 or 4 years, and everybody loves the product, and it's been growing in popularity. And she's like, well, it's too expensive. So I tried to lower the price as best possible. I got quotes for 24 cavity molds, 48 cavity molds. I said, I'll make the investment. Let's lower this thing down to as low as possible so that you can keep it in there. And they didn't go for that. So it kind of fizzled at that point. Yeah.
Interesting. So back to the Tide example, if they went through that exercise of trying to build pouches and all that, why do we still see bottles of Tide on the shelf instead of pouches?
Exactly. Okay. So it was it was getting towards Christmas time that year, and I was picked as a top 4, then I was picked as a top 2. And I was like, I couldn't believe it. I just couldn't believe it. A simple little plastic piece, and I'm picked as a top 2 for Procter and Gamble to be put into a Tide bag. I was blown away by that. What had happened was they didn't analyze, and I'm not sure why, but they didn't analyze the impact of converting all of their lines globally from a bottle filling standpoint to a pouch filling standpoint. It is a different process. It is a different handling process for making pouches and heat and sealing those into bags. And then of course, there was the putting of the handle in place. It had, inline and all that stuff. They didn't analyze this fully, which is crazy that Procter and Gamble didn't do this analysis up front or what have you. And it came down to the senior packaging engineer calling me and saying he apologized after the holiday. And I'm going through the holiday saying, oh my God, this is going to be amazing. And then the holiday ends, January comes around, and they call me and say, saying to me that they didn't do their full homework, and upper management does not want to spend the money to convert all of their plants globally from bottle filling to pouch filling. It would have been a huge boost for them, because when you fill bottles, when you injection blow mold bottles, you're shipping air, and and they wanted to get away from that. And with these pouches, you can stack them 3 times as many pouches as you can get bottles, maybe more. So that's why they wanted to pursue that, to lower cost. But I guess the investment of the capital to convert all of their plants was too much for them, and it never took off. That's why you still see Tide and all of their brands of liquid laundry detergent in bottles.
That's interesting. I mean, I'm sure it would have been a huge investment, but you got to imagine the payback wasn't that long. But I guess they know the numbers. So.
Trust me, I wouldn't be working for Trim-Lok, my current company, today if I was selling 250 million handles a year. I'd be enjoying that. Yes.
Yeah, I can imagine. So you mentioned Trim-Lok. What's your current role? What are you doing these days?
So I'm the director of engineering for Trim-Lok. And let me just step back. The first 20 plus years I spent with product development, it was mostly for injection molding. It wasn't really for another manufacturing process. It's mostly involving injection molding, engineering thermoplastics, and so on for different companies. Biomedical, I worked for Mattel Toys, I worked for Rainbird. When I left to take this position at Trim-Lok is to be the director of engineering, and Trim-Lok is an extruder. They're a custom profile extruder. So it's a different manufacturing process. I'm aware, and I was aware of extrusion, and it's not a sexy manufacturing process. It's a 2D process. Injection molding is 3D, extrusion is 2D. It's kind of like when you were a kid and you're playing with Play-Doh. You put that little flour disc in there, you put the Play-Doh in, you squeeze the handle or push the handle down, and what comes out is an extruded Play-Doh in the flower shape, right? Well, that is extrusion, and Trim-Lok does an industrial version of that. And whether we do rubber and we do plastic.
Okay.
I wasn't aware when I got there. I was like, this is not going to be sexy. It's going to be plain, plain Jane type of stuff. And man, I was wrong, because when I got there, my creativity took hold, and I was solving problems and creating solutions for customers, and it allowed me to use my creativity and create these crazy extrusions where I can combine materials, create features, and we took off. Trim-Lok took off. We were in the beginning, we were very heavy catalog, where Trim-Lok had a catalog. They've been in business for 53 years now. They've always had a catalog, and they had products that the owner created and was selling. And when I got there, they had very little custom products. And then when I got there and I started getting into, I can do this and I can do that, I can combine these materials, and I pushed the boundaries of what Trim-Lok's capabilities were, and we found out, we being Trim-Lok, they found out that, hey, we could do some really cool things. And once we started learning and doing that, my creativity just got stronger and stronger, and we started creating all these products that that a lot of other people weren't doing. And so our custom business took off like crazy. I would say now, if you were to say, what's your percentage? We are 80 to 90% custom.
Wow.
The catalog sells itself. That's a mature product line. Everything that we do and everything that my team works on is brand new R&D stuff, new stuff.
Very cool. You mentioned when you first started talking about it, having different materials. Do you actually extrude different materials, or are they extruded separately and then kind of assembled together? How does that work?
Yeah, so in extrusion, let's take plastic, for example. We do plastic, and what we do is when you have multiple materials, each material is in its own extruder.
Mm-hmm.
So you have the main extruder, which would cover the largest section. We look at it as cross-sectional area of the product. So we put the largest extruder to fill that section. And then let's say you're creating a flap or something, a feature that is a different material. Maybe the main section is more of a rigid material, and the sealing portion of it or the other feature is more flexible, softer material, softer plastic. So we have one extruder running the more rigid material. We have a second extruder coming in at a 90-degree angle, and that's feeding the flexible material into what we call a stacked die. So the one part of the die is getting the rigid material. The other part of the die, the other plate of the die, is receiving the flexible material, and they come together in the one die. And then you're extruding out through the front of it and then into the cooling bath down the line, and there you're able to produce the part with multiple features. We don't just do, that's called co-extrusion, where you have two materials. We do tri-extrusion, we do quad extrusion, and if there's a name for it, we do we do 5. We don't like to do 5 only because you're tying up that many extruders. And when you tie up that many extruders, you can't run those extruders for other products. So we kind of cap it at 4. As long as we have long runs and we're making good money, we'll use 4 extruders. I would say the majority of what we're doing is co-extrusion and tri-extrusion.
Okay.
Yeah.
So when you're doing the co-extrusion, tri-extrusion, everything's still hot, so it bonds together when it meets?
Yes. Yes. So
okay.
Good question. The materials have to be thermally compatible. So if it's a polyolefin material like a polypropylene, what polypropylene bonds well with is other polypropylene or materials that are similar to polypropylene, polyolefins. So we have to keep that in mind. You have to use similar materials that have thermal profiles that match, and so that they can bond. And so we do a lot of what's called TPV, thermoplastic vulcanizate. It's what that is it's a nice long term for EPDM rubber and polypropylene that are mixed as a thermoplastic. It's using a little bit of rubber, with polypropylene, and that's called TPV. The other side of that is TPO, which is the same two components, EPDM and polypro, but TPO is more rigid, so that's more polypropylene than rubber. TPV has more rubber than polypro. So, and basically surrounding those materials, and TPEs, they're called thermoplastic elastomers. I mean, I can get into a lot of chemicals and stuff, but these are all the materials that you can co-extrude. We do ABS with TPEs. We do rigid PVCs with flexible PVCs. We're doing now Hytrel, which is a copolyester with PVC. There's so many different combinations that we work on, and it depends on the customer. It depends on the application. It depends what it is it's doing in the application, on what materials that we use. And the same thing for rubber. Rubber is not very rigid, so you're limited to what you can do from a rigidity standpoint. You can get up to about 85 in the Shore A hardness range. You can get flexible up to semi-rigid. on rubber, but we co-extrude rubber. We put metal through rubber. We do all kinds of stuff in rubber. Yeah.
Cool. You were talking about mixing, I don't remember if it was TPE or another soft material with like polypropylene,
Right.
and then doing the same thing. Is it because of that mixture that you can then co-extrude like a polypropylene with a TPE?
Right. Yeah, it's all thermal. The thermal profiles are matching, so that allow it to bond together. I couldn't take, and chemically wise, they have to be right too. I couldn't take let's say a PVC and bond it with a polypropylene. It won't match. It won't work. It'll never bond together, right? So you have to use similar materials with similar thermal profiles that make that work. Yeah.
Okay. Very cool. Before we start wrapping up, can you like share an example with us of like a fun challenge that you solved, in the custom extrusion area?
Sure. I have many. One in particular, which is I really like this one because it was started from scratch, from complete scratch, was what's called a fender flare. And these fender flares are used along bus fenders, truck body fenders. You see, you don't notice them because you're driving along the road and nobody's looking at the bus like I'm looking at the bus, like, oh, look at that rubber part, or whatever. But if you look at a bus driving down the road, or maybe an RV or whatever, if you look at either the front or back fender, you'll see this black rubber thing surrounding the fender, and that's what's called a fender flare.
Okay.
These fender flares are traditionally made overseas. There are some companies that make them here, but they're made using an autoclave, a pressure vessel. They extrude raw rubber. It's extruded raw, and it's not cured yet. So it's extruded raw in shape, and it's coiled. And that coil, then all the plates of this raw coiled rubber, if you will, that's in a shape, gets then rolled into a giant pressure vessel. They call it an autoclave. And then through heat and pressure, that rubber is cured. And because it's cured in a coiled state, it sets the curve. And that curve looks very nice. And then they cut it to length. And that curve then gets installed with, here's the thing, you have to drill through the fender to install this traditional fender flare. And it looks great. It looks great, but the assembly of it is what I focused on, not the look. It was the assembly of it. Because what they have to do is they have to drill multiple holes around the fender using a template. They have to use stainless steel hardware, bolts and nuts and washers and so on. And that all costs money. And it's a lot of time and labor to install, to drill those holes and to hold it in place and all that kind of stuff. And that's the way it was done. That's the way it is done. It's still being done that way. What I came up with, and what we do, Trim-Lok, we don't do raw rubber extrusion and autoclaving. We do continuous extrusion. So when you put the rubber into the extruder in the very beginning of the line, at the very end of the line, there's microwave cure, there's a salt cure process. So the rubber goes in the extruder, it's extruded, it gets cured, it gets cooled, and at the end of the line, you have a product. It's a completed product, and it's all done in one process. The challenge was, how do I create a continuous extruded fender flare that can have the ability to go around the radius without kinking or buckling and looking funky? And so that was the challenge, but I was up for the challenge. And I took our trim technology on how we install rubber trim with metal carriers onto the edge. And I adapted that. Everybody thought I was crazy. And I adapted the fender flare, the profile of the fender flare, to our trim. And I said, why don't we, instead of drilling holes, we can use our trim technology adapt the fender, extrude it all in one time in rubber, and then we can install it all on the fender. And everybody's like, no, you're crazy. It's going to buckle like crazy and all that stuff. Well, sure enough, it did buckle, and it looked terrible in the beginning. But I solved that problem. I realized that the stress of when it goes around the radius has to go somewhere. As you're trying to put this beefy piece of rubber around the radius of the fender, the stress that's created when you start bending the rubber, it goes somewhere. Sometimes it was going towards the flap and making it buckle and stuff like that. So I created, and this is patented, by the way, I created a hinge. I created this unique flexible hinge that sits there before the trim gets to the trim. And as you bend the product around the radius, all the stresses get absorbed by the hinge.
Interesting.
It really is. And it took me by surprise too. I mean, this was the concept, and I was playing with it, and I was trialing, and I was testing in the lab, and I mocked it up. Again, mock-ups are your friend. They're awesome. And I figured out that hinge was the key. It was the complete key to the whole product. And so what it also allowed me to do was it allowed me to coil the product just like the original fender flare. It allowed me to coil it in a box, allowing the rubber to take a set as it's further cooling in the box. So when they take it out of the box and they install it, it looks perfect. And got a patent on that. Have many customers, and we're selling that thing like crazy. And that's the story of the fender flare. Many products, we have many. I have other products that we've come up with, or that I've come up with, and innovation, and that's my charter with Trim-Lok, is to innovate and come up with new things.
Yeah. That's really cool, really interesting. So just a couple more questions, and we'll wrap up, kind of shifting gears just a little bit. What are some of the trends? Like, I love asking this question because everybody comes at it from a different perspective. So from your world of product development, what are some of the trends you see emerging?
Well, 3D printing is definitely, it's not even a trend anymore. It's like a commonplace thing, right? The 3D printing is going ballistic. We have our own 3D printer in house. We use it for developing fixtures for manufacturing. We use it for our mock-ups for product development. We're using it for everything. So the materials of 3D printing, the speed of 3D printing, all the various processes of 3D printing that you can do, whether it's flexible materials, rigid materials, that trend is through the roof right now, and I don't see any stopping that. That's one of the biggest trends that I see in our business is the 3D printing. It allows us to quickly, basically overnight, see what we've designed and test it, and then we can pivot or change the design and do it again, and it just makes for your development process, to speed up your development process dramatically. But I think that's one of the biggest trends, at least in our industry. As far as from a product development standpoint,
I would agree. And you've been around 3D printing about as long as I have, and like the speed is what's crazy anymore. I mean, you used to have to be so slow just to maintain accuracy, and just how fast these things are printing now with accuracy is pretty amazing.
Multi-material. I mean, back in the 90s, back in the early 90s when I was in biomedical, we would print these SLAs, the very start of this with stereolithography, and we'd print these SLAs, the polyurethane material, and if you dropped it by accident from an inch off the table, it would shatter into a million pieces. They're like, oh my God, I just destroyed $300 in a matter of a second because it shattered. Nowadays, you can throw these things against the wall, and it's crazy. Yeah,
it's pretty awesome. So reflecting on all the challenges and successes and everything you've encountered developing products, what words of wisdom would you share with somebody wanting to make a significant impact in the product development industry?
Yeah, I thought about this question. You have to stay motivated, and you can't let other people because it's like this, if whether you're an inventor or you're an engineer or whatever, people will always try to be a naysayer when you're developing a product, and you got to stay motivated. You have to use failure as your growth mechanism. It's key, because there's so much more that is learned from failure than anything else. And a lot of people, they get they see failure, and they stop. And you cannot stop. You have to use that as a way to pivot your design or whatever you're doing, and then get back on the course. And that fender flare that I just talked about would have never been completed had I stopped when I put it around the radius and it didn't work the way I was hoping. It was like, oh crap, it's not, this looks horrible. I'll never sell this. And so it failed. So I'm like, okay. And then my boss, the owner of the company, was like, forget it, it's over. And I'm like, no, I can make this work. Just give me some time to figure out and analyze how to fix this. And and that's where the hinge idea came up. And that was a great example of failure turning into a design solution, and then success. So I would say use failure to grow, and to and be flexible when you're designing, because you're not going to design it in one shot and have the greatest product in the world. It's going to take time.
I tell people that we get a lot of inventors that come to us, and I tell them I've been doing this almost 30 years and never once have I gotten the design right on the first try. I mean,
now the closest that I got was the handle, and
yeah,
only because it was so low tech and simple. I drew up the handle, and I didn't even draw it where the handle was symmetric. Like I was sitting there like, stupid me, how did you not make this symmetric so that you could feed it, any which way? But it was that experience of the handle not being symmetric that I'm like, and they were telling me, oh, the operators, if sometimes they're feeding it in backwards. And I'm like, oh no. And then that was a failure, right? And I'm like, oh crap, I need to make this thing completely symmetric so the operator doesn't have to think when they insert it. They'll insert it upside down, right side up. It doesn't matter. It's the same every which way. That was failure of the handle initially, the initial design. I converted the design to be more successful. So, but that was the closest thing that I've had to a one and done. Yeah.
Cool. Awesome. This has been great. I really appreciate you doing this. Is there anything else you'd like to mention in regards to any of the products you talked about or product development in general?
No, I mean, I think we talked about everything. I mean, if there are inventors listening right now, I would say I'm an inventor. I'm an entrepreneur. I started my own development company, in my career. I've worked for various companies. And if there's an inventor listening on this, I would say, don't give up, stay motivated, and use failure to succeed, because that's what it takes. It really does. And you have to, and everybody wonders, and they look at people and they see people that are successful, and I'm like, man, I would love to have that. But what they don't realize, maybe they don't realize, is that person went through probably years of pain and struggling and trial and error and failure to get to that point. It's rare that you have a one and done and you just take off. So you have to stay motivated. You have to just keep at it. And it does take money, and it does take time. And the difference between people that are successful and people that aren't with inventing is that the people that are successful, they stay with it and they keep at
it. Yeah. That's awesome. I really appreciate you doing this.
Yeah, thank you very much for having me. This is great.
To learn more about Impulse and how we might be able to help you, visit impulseproductdevelopment.com.